Okay? All right, let's finish up this page. Actually, we got to do number 8 first before we do that. Okay. It's important that when you guys go to take this final that you know a couple things. You have to know what this produces, what this produces, okay, what this produces. Do you guys know what these look like? Let's make that a 3. Right? Like, what is this? What is this top one? Anybody know? Yeah, this is a line, okay? It's a line. What is this one? Good, that's a parabola. What's this? It's not a sine graph. Yeah, it's like a squiggly that looks like this, okay? Now remember, even ones are going to have the same end behavior, and then odd ones are going to be going in opposite directions. Okay, what about something like this? What is this? Good, that's a circle, right? So we need to, that helps us when it goes to graph it. Okay, what about something that looks like this? That's an x. Yeah, this is an exponential equation, and it's either going to be growth or it's going to be decay. Decay looks like this, where it comes down. Okay? Now, from that, you can have different variations. Where, like, let's say that we had this exponential growth, but it was flipped over the x-axis. If it was flipped over the x-axis, it would look like this, right? Okay? And then if we had exponential decay flipped over the x-axis, then we'd have something like this, where it would be like, okay? So that's going to help us here. We know that it's going to look something like this, and the easiest thing to do is just to come up with a t-chart, because I could tell you things to remember, but that's just going to make it confusing. So let's try a t-chart real quick. If we put in 0, what's 2 to the 0? 1. What's 1 minus 3? Good. So at 0, we go down to -2 and put a dot. Okay, now let's try 1. What's 2 to the first power? 2. What's 2 minus 3? Good. So at 1, it's -1. So it looks like it's increasing going this way, right? So this one might be exponential growth. So let's just go crazy and try 3 real quick. If I put in a 3, what's 2 to the third power? 8. Okay, so 8 minus 3, that's going to be 5. So at 3, which is right here, it's going to go all the way up to 5. So 1, 2, 3, 4, 5. Okay, so definitely this thing is increasing going up like that. Okay, now we want to know how far it comes down and where does it start to ride that line. Okay, so let's try some negative numbers. If I put a -1 in here, that means that that's going to be 2 to the -1. What's 2 to the negative first power look like? Yeah, that's 1/2, right? Or 1 over 2 to the first. Okay, so now what's 1/2 minus 3? Like if you had $3 and you spent 50 cents, how much do you have? Okay, you guys don't spend that type of money anymore. Okay, so at -1, it's at -2.5. So -1, it's at 2.5, which is down here. Okay. Now, if this was a 2, that'd be 1 over 2 squared, which would be 4. So if you had $3 and you spent a quarter, how much money would you have? Good. Okay, so that means at 2, it's going to be a little bit closer. Now, will this number ever beat out this 3? Like, will we ever go beyond -3? Like, for example, let's say 2 to the 10th. 2 to the 10th is going to give us this answer here. Let me move this out of the way. 2 to the 10th is going to be 1 over 1024 minus 3. Will that ever... Yeah, all that's going to do is just get really, really close to this line. So we know then that this guy is going to kind of go like this, and it's going to ride the line right here at -3. So what does that mean -3 is? Good. It's an asymptote. So do you guys see how it's at the rear of the problem? Since it's at the rear of your problem, that's going to be your asymptote. Okay? That's an easy way to remember. Okay? So rear of the problem, that's your asymptote. That's how you graph it. So that should help us for these next couple ones down here. Okay? All right, so we're going to skip ahead and do C and D. These are exponential equations. Now, do you guys see how this one comes down and it rides the line right here at 0? So that means our asymptote is at 0. So all of the rear of the problems are all 0. Okay, now is this exponential growth or decay? This is decay. Now, decay is kind of weird. We can tell that it's decay by looking at the equation and we see a fraction that's going to be squared or raised to a power. This is going to be decay, and then also if you have 2 to the negative x, if you have a negative exponent, you have to change that into a fraction, okay? So these are going to be the scenarios where you have decay. Alright? So, looking at this one is not decay. There's no negatives and there's no fractions, so it's not this answer. Now this one has a fraction, but I don't know. Maybe we'll keep that one in mind. Now this one is negative in the front. Now negative just means it's going to reflect over the x-axis. So instead of exponential growth, it's going to be exponential growth but going down like that. And that's definitely not what's happening there. So it's not that guy. Now this is going to be exponential decay, but it's going to be reflected over the x-axis. So decay looks like this, so this one's going to look like that, which is not the case. So then that one has to be B. Okay? These ones could be easy because I see that there's an asymptote right here at -1. So I just have to find where the rear of the problem is -1. That's my answer. Okay? Up top, this is definitely going to be a cosine. How I would do this one is look at this and say, okay, here's that middle line. This is going to be my amplitude. Okay, so the amplitude looks like it's 1, so it can't be this, and it's definitely not a tangent function. Okay, so it's either got to be one of these guys or this guy. So let's see. It was shifted down 2 units, so it's got okay. It's one of these guys. Now, is it a sine graph? Does it look like a sine? No, so it's not sine. This was a flipped over the x-axis cosine graph. Got to be this one. Now over here, this one is definitely not tangent. This is a sine graph that's been reflected over the x-axis. So this is the only sine. So that's how you do that.